So good morning students, welcome back. This will be the second lecture on this chapter unit and dimension. As you know, last time we discussed fundamental units, okay, physical quantity, types of physical quantity, units, derived physical quantity, dimension, unit, okay. Now today I'm going to tell you the different important, okay, dimension of physical quantities. So let's start with first, that is one of the most important, force. One by one I'm going to find the unit and dimension for all. So first of all, I'm going to start with force. That is one of the most important. Okay, force. We'll not discuss here what is force and the types of force, and because here we need only the formula. Later on we'll discuss about force, work, acceleration in the coming chapter. So okay. So here we need only formula. Everyone knows that what is the formula of force? Force having formula mass into acceleration. This is the famous form, okay, by second law of motion, F equals to ma. Okay, now students, we'll open the formula until it can be open. Okay, mass remains m as it is, acceleration we can write as velocity by time. In short, I'm going to write v by t. Acceleration is what? Velocity by time. The rate of change in velocity is called acceleration. Okay, mass as it is, and velocity we can further open as displacement by time. We written as d by t, displacement by time, and that time as it is. So now it is completed. Mass we can write as m1, as last time I explained. Displacement we can write as l1. Okay, and this is the time. T1 and T1 shift upwards. T1 and T1 T2, when we shift upwards it become T minus 2. So this is the dimension of force that is most important. Learn it also, because in that coming dimension we can use directly for force m1 l1 T minus 2. That is dimension of force. Now it's unit, that is the important part. So see the unit. Actually we always use which system? MKS. But force is an important physical quantity, so that's why I'm going to find its unit in MKS system as well as in CG system. Okay, so see students, we'll find for mass. First of all, I'm going to find in MKS system. First, look, for mass we use kilogram, for length we use meter, and time second. Okay, second minus 2, so we can write as second square. So kilogram into meter upon second square, and that's equals to 1 Newton. On behalf of the name of scientist, it is written as Newton. So basically, what will be the unit of force in MK system? Newton, and 1 Newton consists of kilogram into meter upon second square. Okay, so this is in MK system. So now I'm going to find one more system that will be in CGS. Generally, we'll always find unit and dimension only in one system, MKS. But force and work, these are an important physical quantities. So we'll find its dimension in MKS as well as in CGS. And in gram, okay, length is written in centimeter, and time that always remains same in all system, MKS, CGS or an FPS, second. There comes second square, and gram into centimeter upon second square. That's equals to 1 dyne. Dyne is the name of scientist. Okay, so Newton is the unit of force in which system? MKS, while dyne is the unit of force in which system? That is in CGS. Okay, so you can take a screenshot. Okay, you can copy this. Hope so. Have you understood this? Okay, now I'm going to find the second one. That is what? Work. Okay, look at students. First of all, again we need only formula. We'll not discuss in that in a deep. We'll require only the formula for finding unit and dimension. The first one, next one is what? Work. What is the formula of work? Okay, simple. Work done is always risen at force into displacement. Okay, work done. W equals to F dot S, that is vector form. Later on we'll discuss in 6th chapter. In 11th class, work done, force into displacement. Okay, force, we can open the formula. We can write here force as m into a, mass into acceleration. but we just did in the previous one dimension of force. What is the dimension of force? M1 L1 T minus 2. So we can write M1 L1 T minus 2. And if you want to find, then you can open the formula, force mass into acceleration, and further acceleration as velocity by time, and further velocity by displacement time. Otherwise you can learn it also, because force are an important dimension. It will use, as I told, that it will use again and again. So directly I am going to write M1 L1 T minus 2 dimension of force, and displacement written as L1. So M1 L1 L1, when base change and power is added, so that become L2 and T minus 2. So that is the dimension of work done. Okay, that is another important dimension. M1 L2 T minus 2. Okay, that is the dimension of work done. Now what will be its unit? Again, I'm going to find in both the system, MKS as well as in CG system. First, I'm going to find in MKS system. Okay, what will be MKS system? Mass, kilogram, length, distance in meter, so meter square, and time, second square, and kilogram into meter square by second square. That's equals to 1 joule. So basically, what is the unit of work in MKS system? That will be joule. Okay, students. Now, students, that was in MKS. Now I'm going to find in CJ system. Kilogram replaced by gram. Okay. Meter replaced by centimeter square, and second remains same in all system. So gram into centimeter square by second square, that is the unit of work done in which system? CGS, and that's equals to 1 erg. Erg is the name of scientist. Erg. Okay. So joule is the unit of work in MKS system, while erg is the unit of work in CGS system. So you can write this and learn it also as like force. What was the dimension of force? M1 L1 T minus 2, and here M1 L2 T minus 2. Okay, so this second has done. Now students, for finding third, look at students, third is energy. I will tell you, all types work is a form of energy. Work done is a form of energy. So work having the similar dimension of energy. All types of energy. Potential energy, okay. We can write kinetic energy. We can write, okay, mechanical energy, okay. Any types of energy, sound energy. So work having similar as like energy, because work done is said to be energy. Okay, the capacity of work is called energy. So energy is all types of energy, including potential, kinetic, mechanical, sound energy, having similar dimension to work. So what should be the unit of energy? Dimension of energy M1 L2 T minus 2. And what will be its unit? Same, its unit is like joule. So remember, whenever there comes energy, so energy having similar dimension of work, because work is a form of energy. Okay, so this process we have to follow again. Okay, and there comes joule. Understood? Now students, next is power. Now I'm going to find the dimension of power. I'm going to remove this. Students, power. What is power? Rate of work done. Ability, the capacity of work done is called energy, but rate of work done is called power. Power having formula work by time. Rate of work done is called power. So what should be the power? Work done. Okay. Work, if you don't know, you can open the formulas one by one. Like work, we can write as force into displacement, and then further force is replaces mass into acceleration. But that will be too long process. We know. Always learn the dimension of force and work done, because it will use again and again. We just did. What is the dimension of work done? M1 L2 T minus 2, and time, that is T1. So we can write as M1 L2 transfer T1 upwards. Okay, this plus 1 become minus 1, so that become T minus 3. So M1 L2 T minus 3, that is the dimension of power. Okay, now what will be its unit? For mass, we can use kilogram in MK system. Length in meter, they become meter square. Okay, and time second. minus 3 then what? Second cube. Okay, first of all we found unit by this dimensional formula. This is called dimensional formula. We can also find using by this initial formula. How? What is the unit of work on behalf of the name of scientist? That is joule. Okay, and what is the unit of time in a, that is second. So one we found by dimensional formula, another we found by that formula. Okay, and joule upon second, that's actually 1 joule by 1 second, that is called 1 watt. So basically what is the unit of power? We generally will use watt, and 1 watt consists of joule per second. Understood, students? So this is dimensional power. Next is what? Pressure. So what should be pressure? Actually pressure is what? Force exert on per unit area perpendicular to the surface is said to be pressure. So here we just need formula pressure. Pressure having formula force by area. Okay, force exert. Suppose you are having a surface and force, air is exerting force on its per unit area particular. Okay, so force exert on per unit area is said to be pressure. We just need the formula. So basically what is pressure? Pressure having formula force by area. Again we know the dimension of force. What is the dimension of force? M1 L1 T minus 2. Okay, students, and that area length into breadth, L into L, we did just in the first lecture, so it become L square. So M1, okay, transfer L to upwards, L minus 2, minus 2 plus 1, L minus 1, and that is what? T minus 2. That is the dimension of pressure. And what will be its unit? First by this formula. Okay, mass in mk is kilogram, minus terms always comes in denominator, for length meter, and for time second square. This unit I found by the dimensional formula. As I told that we can also find by the initial. So what will be by that formula? What is the unit of force? We know the unit of force is Newton, and the unit of area is what? Meter square in mk system, and Newton by meter square is called Pascal. Pascal is the name of scientist. So basically what is the unit of pressure on behalf of the name of scientist? That will be Pascal. Okay, students. Now students, next is stress. Stress is what? Stress is just similar to pressure. Same like stress having formula force by area. Dimension of force M1 L1 T minus 2. Area L square. So M1 L minus 1 T minus 2. That will be dimension. Stress, force exert on per unit area is said to be stress. Okay, that is related to elasticity. We'll discuss in chapter number 9 in 11th class. Okay, and same unit we can write for finding unit. We'll always unit a single system, that is MKS. Okay, M for meter, K for kilogram, S for second. For mass we use kilogram. Minus terms comes in denominator, L minus 1 meter and second square. Stress is similar to pressure. Now strain, that is important. I'm going to tell you about strain. Actually strain, a physical quantity having formula change in configuration by original configuration, change in dimension by original dimension. So for explaining that, I'm going to make a diagram. Suppose we are given a wire. Okay, that is the elastic wire and its original length is L. Okay, when we attach some weight with it, it will be stretched, okay, by the length delta L. So that is the original length of wire, and that is change in length of wire on applying weight with it. Okay, it will be stretched. Now students, so how can we define strain in such case? Strain having formula change in length by original length. What is change in length? That is delta L, and original length is L. But one thing is there, change in length. Change in length is just a type of length that answer will come in the value will come in length only. Delta L, change in length, it is considered as L1. Okay, because we know, as I told, that depth, height, radius, okay, length, breadth, all represented by L. So change in length represented by L, and original length, that is also by L. L12 cancel out. There is no mass. M0, L0, T0. It means strain is a dimensionless physical quantity. Change in configuration by original configuration, change in length by original length, change in dimension by original dimension. So it is a dimensionless quantity. And when there is no dimension, okay, and it is also a unitless physical quantity, because length meter, change in length will measure in meter, original length we also measure in meter, meter to meter cancel out, so it is also unit length. So it is massless and unitless physical quantity. That is one of the most important point about strain. Okay. Now students, the next is 3 connected physical quantity. Angle, it is also said to be angular displacement. Angular displacement. Okay. Then angular velocity and angular acceleration. These 3 all are attached, all are connected. So one by one I'm going to explain all that 3. Okay. Now students, we'll start with angle, or it is also said to be angular displacement. Okay. Look students, suppose an object is moving along the circular path. Okay, like this. O is center, R is radius, A is the initial point of motion, and B is what? Final point of motion. An object is moving along the circular path. That is initial point of position or position of object, and that will be the final position of an object. Okay. And this distance, this curved distance, okay, is represented by delta S. That is the arc. Okay. Delta S, small distance. Okay. Okay, this angle is theta. So angle is what? What is angle? Actually, angle is a physical quantity. Change in position. Okay, angle is defined as change in position. Okay, of an object with respect to center along circular path. Change in position along circular path with respect to center is said to be angular or angular displacement. In other words, arc by radius. Change in position of object with respect to center is called angular displacement. Okay. Angle is what? Angle is represented by theta. Arc, this distance AB is called arc, and radius we are given as r. Arc considered as delta S, we assume delta S, and radius r. Now students, simple thing. Arc, that is the types of a distance, and distance always represented by L. And r, radius, it is also types of distance L. L2 will cancel out, M0, L0, T0. That is also a dimensionless physical quantity, M0, L0, T0. But it having the unit, its unit is what? Radian. What is the unit of angle? Angle will always measure in radian. Okay. So the unit is radian, and there is no dimension M0, L0, T0. Now students, simple. Next is angular velocity. We know what is simple velocity? Displacement by time. Rate of change in displacement is called velocity. Okay. Look students, what is simple velocity? Rate of change in displacement is called velocity. Just like what will be angular velocity? Rate of change in angular displacement is called angular velocity. So now we are going to find next one is angular velocity. Okay. Angular velocity represented by the sign omega. That sign is called omega. Okay. So having formula, angular displacement by time. Okay. this sign is said to be omega. We can write here that sign is called omega. That is a W-like sign, that is called omega. Rate of change in angular displacement is called angular velocity. Angular displacement, just we found no dimension, m0, l0, t0, and time there comes t1. So m0, l0 and t minus 1. Transfer t upward side become t minus 1. Okay, that is dimension. And what will be its unit? No mass. Okay, no length. Okay, we can find by that formula. Angular displacement, angle we measure in radian, and time we measure in second. So its unit will be what? Radian per second. Now the next is angular acceleration. Just like angular velocity, we'll replace in this angular acceleration. Actually, what is normal acceleration? Rate of change in velocity is called acceleration. Just like for angular acceleration, right? Rate of change in angular velocity. So angular displacement represented by angular velocity, and we know what is about angular velocity. m0, l0, t minus 1. Okay. So what will be the, and this time it is represented by alpha. Angular acceleration represented by alpha. Okay. So finally we can write m0, l0. Shift t1 upwards, t minus 1. Minus 1, minus 1, it become t minus 2. So what will be the dimension of this angular acceleration? m0, l0, t minus 2. Now students, unit again we can find by that. Angular velocity having radian per second, and time is having the unit second. So radian second upon second into second, second square. So radian by second square. That is a unit of angular acceleration represented by alpha, and that is the dimension. Now students, now I discuss the remaining three dimension. Surface tension. Next is what? Surface tension. How can you find surface tension? Actually, before discussing the numerical, okay, based on dimension, we have to know the dimension properly. Okay, if you know the dimension properly, you can easily solve the numerical based on dimension. Okay, there are three applications to dimension. Okay, later on we'll discuss one by one. It's all application and numericals based on it. Before that, we'll discuss how to find dimension properly. Now next is what? Surface tension. What is surface tension? Actually, suppose that is the liquid force exert on per unit length of the liquid is called surface tension. Okay, surface tension represented by F is represented by S or T. S means surface, T means tension. So we can write here T. Okay, force by length. F means what? Force. And L is what? That you know, length. Force exert on per unit length is said to be surface tension. We know, we just did the dimension of force. What is the dimension of force? Yes, m1, l1, t minus 2. And for length, l1. L1 to l1 cancel out. So what will be dimension of surface tension? m1, l1 to l1 cancel out, l0, and that is what? T minus 2. And what will be its unit? For mass, kilogram, no length, time second square. So kilogram upon second square. First by dimension formula. I found its unit by dimension formula. We can also find by that. Yes, how? What is the unit of force? Newton. What is the unit of length? Meter. So Newton upon meter. That is another unit of surface tension. Class is coefficient of elasticity. About this coefficient of elasticity, properly we'll discuss in 9th chapter elasticity. But here I'm going to write the formula. Okay. There are actually the ratio of stress. The ratio of stress with strain is said to be coefficient of elasticity. That is coefficient of elasticity. Okay. It is represented by, suppose, E. Stress having formula force by area, and strain, change in length by original length, change in configuration by original configuration we did. So we know it is dimension is M0, L0, T0. Force having unit M1, L1, T minus 2. Force, okay. And area, length into breadth, L into L, L square, and that M0, L0, T0. If you don't want to write, no issue. Finally, what is the dimension of coefficient of elasticity? This is M1, shift L2 upwards, L minus 2, minus 2 plus 1, L minus 1, and this is what? T minus 2. That is the dimension, and what will be its unit? Okay, mass, kilogram. Minus terms always comes in denominator, length, meter, time, second square. Okay, so kilogram upon meter into second square, and we can now students, the next dimension is Planck constant. It is related to photon energy. Photon energy is small packets of energy that is absorbed and released by electron. Okay, we'll discuss in the coming chapter. Here I'm going to write only the formula. E equals to h nu. This is called photon. E is called photon energy. That is called photon energy. Okay. H is constant, that is called Planck constant, and nu is frequency. So finding H, there comes E by nu. E is called photon energy. Just we did in the beginning. All types of energy similar to work done. Yes, what is it of work done? M1, L1, T minus 2. Simple. And frequency, reciprocal of time period. Listen, reciprocal of time period is called frequency. 1 by T. Either we can write T minus 1. So frequency replaced by T minus 1. So M1, what will be dimension? M1, L1, shift T1 upwards, T minus 1 become T plus 1. Plus 1 minus 2, T minus 1. That is dimension. And what will be its unit? On behalf of the dimension formula, for mass, kilogram, for length, meter, time, second. Either we can find by this formula also. What is the unit of energy? Joule. All types of energy having the unit joule, and frequency having hertz. It is short, it is written as Hz. So joule upon hertz are the kilogram into meter upon second. So that is important physical quantity, Planck constant. So we found the dimension of all physical quantities. So look students, now I'm going to explain some important dimension. Okay. Next is students, coefficient of viscosity, eta. This sign is called eta. Actually, about coefficient of viscosity we'll discuss in 10th chapter. Okay, fluid mechanics. But here I'm going to explain just in a simple way that two layers of the liquid. Okay, two layers of a liquid experience an opposing force, and that force is called viscous force. That is called viscous force. That is an opposing force experienced by two layers of liquid, and that the formula of this viscous force is given by F equals to eta A dV by dx, where F is force, eta is constant, that is called coefficient of viscosity, A is area, okay, and dV is velocity, and dx is what? Displacement. Okay, so and this term is called velocity gradient. This term is called velocity gradient. So we require eta F into cross multiply F into dx divided by A into dV. Okay, force. What is the dimension of force? Yes, M1, L1, T minus 2. Displacement L1. Area, as you know, length into breadth, L square, and velocity, displacement by time, L1 and T minus 1. Okay, so solve this. M1, look at L1 to L1 cancel out. When transfer L2 upwards, minus 2 plus 1, L minus 1. When transfer T minus 1 become T plus 1, minus 2 plus 1, T minus 1. So that is the dimension of coefficient of viscosity. Actually, this is called viscous force. Force between two layers of liquid. Okay, so we'll get the dimension of this constant eta, M1, L minus 1, T minus 1. Now, what is the important thing? Its unit. For mass, kilogram, length, meter, time, second. First, we found by this dimensional formula. Remember, the form of MLT is called dimensional formula. we can find by that formula, in this formula, by that formula. What is the dimension of force? Newton. Distance, meter, area, meter square, velocity, meter per second. So look students, meter to meter cancel out. It will be what? Newton into second by meter square. That we can also find. And we know Newton by meter square is called Pascal. So one more unit may be there. Pascal into second. Understood, students? Now students, I'm going to find four important dimensions. Five important dimensions: electric charge, electric potential, resistance, magnetic field and electric field. So let's start with electric charge. Okay, actually charge is a property of particle, okay, that can generate electric field or magnetic field. So having formula, look students, the first is electric charge Q, having formula current into time. But in the in the 10th class, I equals to Q by T. The rate of flow of charge is called current. So that charge will comes as current into time. Okay. Actually there is no mass m0, no length L0. For time T1 and current is represented by A, ampere. Remember the fundamental quantity? There are 7 fundamental quantity: mass, length, time and ampere also. If temperature is there, then Kelvin also. Okay. So M0, L0, T1, A1, that is a dimension of charge. Now what will be its unit? Okay. Look at time, current, ampere and time, second. And ampere into second we can write as coulomb. So either coulomb or it is ampere into second. That will be the unit of electric charge. Now students, the next is what? Next is electric potential. This electric potential. I am going to find about electric potential. What is potential? Now this is second one, electric potential, represented by V. Now next is electric potential. Work by charge. Okay. Work by charge is said to be potential. Work is what? M1 L2 T minus 2. We did. And charge just we have written M0 L0 T1 and A1. Okay. T is time and A is what? Ampere. So M1 L2 transfer T1 upwards, that become T minus 3 and A minus 1. That is the dimension. And what will be its unit? First we'll find by dimension formula. Okay. For mass, kilogram, length, meter square, minus terms comes in denominator, time, second cube, okay, and current that you know we always measure in ampere. But we can find by that formula also. What is the unit of work? That is joule. And what is the unit of charge? Coulomb. And joule upon coulomb is called volt. 1 joule by 1 coulomb is said to be volt. So basically, what is the major unit of potential? That is volt, and 1 volt consists of 1 joule per coulomb, and that is a dimension. Now, students, resistance. What is resistance? The disturbance, the hindrance, okay, the obstruction in the flow of current, in the flow of charge is called resistance. Okay, it minimizes the current. So we know by Ohm's law, V equals to IR. The famous form that you did in 10th class, V equals to IR. V is potential, I is current, and R is resistance. So R will be what? V upon I. V is potential and I is current. Okay. Potential. Okay. What can we write as potential? V equals to work by charge and that current as it is. Okay. Current we can write in ampere. What is unit of work done? M1 L2 T minus 2. Okay. And what is unit of charge? Just read Q equals to IT. Current into current into time means ampere into time. A1 T1. Q IT, current for A, time for T. So A1 T1. Understood? And that ampere A1. So finally we can write as M1 L2 T minus 3, A1 A2 transfer upwards, A minus 2. That is the dimension. And what will be unit? We can find by this, okay, for mass, kilogram, for length, meter square, time, second cube, and that is ampere square. But better is to find by that, okay. What is unit of potential? Volt. And what is unit of current? Ampere. And volt per ampere is called ohm. So what, and instead ohm, you can make that symbol also did in 10th class. So what is the unit of resistance? Ohm. And 1 ohm consists of 1 volt by 1 ampere. Either you can write by this dimension formula. And M1 L2 T minus 3 A minus 2. That is dimension of resistance. Okay. Now next is magnetic field. Actually about magnetic field discussing that in class 12. Whenever a charge enter in magnetic field, okay, that is represented by vector B. Whenever a charge enter in magnetic field, it experiences force, and that force is given by F equals to Q V B sin theta. Okay, and we'll discuss also this is called magnetic force. We'll discuss in 12th class. Here we need only formula. Okay, we have to find the unit of magnetic field B. Magnetic field represented by B. So F upon, okay, we have to subject to magnetic field. F upon Q V sin theta. Now force M1 L1 T minus 2, charge A1 T1, current into time, and V is what? Here V is velocity and displacement by time, L1 or T minus 1, and theta, sin theta is angle. We did just before. There is no dimension of angle M1 L0 T0, dimensionless. So what we'll get? We'll get as M1, okay, L1 to L1 cancel out, okay, L0, T minus 1 to T plus 1 cancel out, this is T minus 2, okay, transfer A1 upwards, so that is A minus 1, that is the dimension. Okay, and what will be its unit on behalf of dimension formula? For mass, kilogram, no length, time, second square, current, so that is come ampere. Okay students, this equals to 1 Tesla. On behalf of the name of scientist, what is the unit of magnetic field? Tesla. Now students, the last one is what? Electric field. Now we are going to find the dimension of electric field. Okay. About electric field, will now students, electric field. When charge placed in the state of rest, so it produces an attraction field around that charge, that is called electric field. Actually electric field having formula E equals to F upon Q. Force exert on per unit test charge, force exert on per unit charge is said to be electric field. Electric field having formula force by charge. Okay, so now we can write force M1 L1 T minus 2 and charge A1 T1, current into time. So what will be the dimension of electric field? M1 L1 transfer T1 upwards, T minus 3 and A minus 1, that is the dimension of electric field. And students, what will be its unit? We can find by that. What is the unit of force? Unit of force Newton, and unit of charge Coulomb. Okay, so Newton upon Coulomb, N by C. Force M1 L1 T minus 2, charge current into time. Okay, so A1 T1, In this we'll get the dimensional unit of electric field. Now students, in next lecture we will discuss about application of dimension. There are 3 application of dimension. One by one we'll discuss all the application including numericals. Okay students.